afternoon, students. I hope you will be fine. Today, our practical is set up a microscope. In this experiment, you will be able to understand the working and parts of the microscope. Students, as you know, that the microscope is an instrument that is used to see objects that are too small for naked eye, such as bacteria, tiny cells. The microscope show a magnified image of object. The microscope has two systems of lenses for greater magnification. One lens is eyepiece, which is close to eye or through which we can see the image, and the second lens, which is close to an object, is called objective lens. Both lenses are convex in nature. Since in compound microscope two lenses are used, so it is called compound. Students, the material required for this practical is optical bench, a lens of focal length 10 centimeter, another lens of focal length 5 centimeter, lens holder, uprights, a meter rule, and two upright needles. Okay, students, will perform the practical setup of microscope. The apparatus that we use are two convex lenses, meter rule, and the optical bench. On the optical bench we have lens stand and needle stand. This is the object needle and this is the image needle. Student, first of all we have to find the approximate focal length of a given lens. To do this job we have to get the brighter image of an object like window on the opposite wall of the room, that we can say screen. So you can see here that using the lens I am getting the image. Here you can see the clear and sharp image of the window. When we move the lens toward the board or away from the board, image get blurred. We have to note that position exact where we can see a sharp and bright image. So when we get sharp and bright image, then we have to note the distance between the board and the lens by using meter rule. This is our approximate focal length. Okay students, now the lens whose focal length we find is 17 centimeter. We fix it in the lens stand approximately at the middle of the optical bench. Here you can see we fix it at 50 centimeter. Now we fix the object needle. As you can see, the object needle is this. We have to put a paper over it to differentiate it from the image needle, and this is our image needle. Now we have to put the object needle approximately at 2f from the lens. As the focal length of the lens we get 17 centimeters, so we place a needle 34 centimeter from the lens. Here you can see. Now we have to see the image of that needle from the opposite side of the lens, I mean from the other side over the image needle. And here you can see the inverted image clearly. Students, you can see the inverted image needle tip is exactly coinciding with the image needle tip, and we have removed the parallax. Parallax is that when we move our eye left or right, both needle tips move together. If they move separately, then there is parallax. Okay students, now I will show you the parallax. You can see when we move our eye left or right, both needles move separately. I mean their tips are not coinciding. So this condition is called parallax. Okay students, as you can see the clear inverted image of the objective needle in the lens, that is objective lens. Now we'll use the second convex lens, which is used as eyepiece and have the larger focal length as compared to the objective lens. Here we use the lens whose focal length is 27 or 26 centimeter, whereas the focal length of our objective lens is 17 centimeter, and you can see the magnified image through the lens eyepiece. As students, you can see we place a second lens called eyepiece, and now you can see the larger image as compared to the previous image. This image is seen through the eyepiece. Now we'll move the eyepiece lens toward or away from the objective lens, and we got the image large and large than the previous. So this is the practical for today, the arrangement of microscope.